Welcome to InnoBuzz Java video tutorial part 4. In this chapter, we are going to talk about statement controls. What do we call statement control? These kind of statements let us to be able to supervise how the program will work. They can be the following types: loops, conditional statements, switch statement, break and continue, and compound statements. Let's talk about loops now. What is a loop? What is it good for? These statements allow us to tell the computer to repeat one program part several times. With a loop, we can go over the elements of an array, for example, or we can go through a program part several times according to a conditional statement. What kind of loop types are in Java language? The for loop, the while loop, the do while loop, and the enhanced for loop, which is only available from Java 5. Now let us talk more detailed about for loop. For loop is the most complex loop statement in Java language. Every for loop has a special variable called index or counter. The statement starts with the keyword for, which is followed by 3 sections. In the first section, which is called initial section, we have to give an initial value to the counter. We also have the possibility to declare the counter here, but this can be done elsewhere as well. The second section is the conditional section, where we have to set up a conditional statement that determines whether the cycle should go on or stop. The third is the change section, which allows us to change the value of the counter variable after the core of the loop has run. In this section, we typically increment or decrement the value of the counter. Now we have 2 brackets here, an opening and a closing one. Between these brackets, there is a part of the program code that we want to repeat. Note that it is not obligatory to use brackets after the 4 statements if you want to repeat only one statement. I'm going to show you now how the for cycle works in practice. I have already set up a simple test project here, which is in a test project package, a simple test project class. It only contains a main method. I'm going to write simple for cycles now. For cycle starts with the keyword for, and as I mentioned, there are 3 sections here. The first is the initial section. I declare an integer here named idx, which starts from 0. In the second section, which is the conditional section, we are going to create a condition here, something like idx is smaller than 100. And the third part is the incremental part, or the change section. We change the value of idx here. And this is how for loop looks like. Yeah. I'm gonna add a little code here. Just system out print. To be able to see what's happening. Forgot the T. Okay. Well, we say that the second power of IDX is the space here, IDX multiplied by IDX. Yes. Now let's try it out. Save it and run. Yes. We can see all the powers. Everything is good mathematically, but I don't like that it starts from 0. So I make a little change. We can start from any number, of course. Let's start from 1. And I want to go until 100. So I change it from smaller to smaller or equal to 100. This way we are going to get a better output. Yes. This time we went until 10,000 and from 1. Now this is about it. We can do a lot of other things as well. Let's try now to go down, for example, from 100 to 10 or something, and let's decrement this value. So we are going from 100 to 10 decremented. The same thing. Let's save it, and I'm going to run it. Nothing happened. Yeah, because I didn't change the condition, and IDX started from 100, and of course it is not smaller than 10, so the condition was not true, and there were no loop cycles. Okay, now we change it. This is the only thing that we had to do. You can see that sometimes in programming, changing even one character in the program code can make the program work totally different. Yeah, you can see it starts from 100 with the power and goes down, 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 down. Okay. Now let's try something else. We can use other things here, not only decrementing with 1 like this. We can use, for example, we can go faster. We can use -5, minus equals 5. This means we are going to decrement it with 5 every loop cycle. And let's see it now. Yes, it starts from 100, and every 5th number we can see. We can do a lot of other things. I'm not going to try all the possibilities. I only will do something like add more lines here. So after the for cycle can come a program block with more and more things. Oh, sorry. I just wanted to copy it. Okay. So we can add another line here, something like we can write that there's a new integer called anything a, and this is idx um, plus idx multiplied by 7 plus 12, 20. Okay, this is a, and we are going to say that the value of a is a. I think it's okay this way. So now we have multiple lines in the brackets, these curvy brackets. This means that they belong together. They are all part of this for cycles. Each time the cycle goes, these will run. These will be executed. So I run it now. Yes. We have all the lines here. It's a little bit hard to see what's happening, so maybe we can put an extra line here, or just simply write paren here. This is going to give an extra line. Yeah, so after all the lines comes an empty line. The second power of 100 is 10,000, so you can see it works. Alright. Value of A is 685. Yeah. All the numbers are changing just as we expected. Now this is basically about the 4 cycles for a start. Let's see now how the while loop looks like in details. The while loop is more simple than the for loop. It starts with the keyword while, followed by round brackets that contain a conditional statement which is called while statement. This tells the program to continue repeating or to stop before the statements in the loop have been handled. After the round brackets come the program part that needs to be repeated, surrounded by curly brackets, which are also optional to use if there is only one statement in the loop. If the condition is false, the program jumps over the core of the loop to the program parts that are after the end bracket of the while loop. If the condition is true, the program part inside the loop will run, and after that, the condition is tested again. If the condition does not change during the loop, the cycle goes on and never stops. This is called infinite loop. Now let us go in details about the do-while loop. This is similar to the while loop, but the conditional statement is after the core of the loop. This kind of loop starts with the keyword do, followed by the program parts inside the curly brackets, and the keyword while is after the core of the loop. This means that these statements will run at least one time before the conditional statement is going to be checked. So one loop is guaranteed. After that, the condition is tested, and if it is true, the core program part will be repeated again and again until the condition is changed for some reason. When the condition becomes false, the loop will stop and continue on the further program lines that are after the do-while statement. Note that the do-while loop can become an infinite loop, just like the while loop. if the condition never changes. There is another kind of loop called enhanced loop, which is only available from Java 5. This kind of loop is a relative of the normal for loop, but this is easier to use for arrays and collections. We can write simple and easy readable codes with this loop type. It's like an automated for loop that goes through all the elements. The enhanced for loop starts with the keyword for followed by round brackets. And in these brackets there is an element variable which has to be of the same type of object, that's the array or collection that we are going to loop. The variable declaration is followed by a colon, and then comes the name of the array or collection. After the enhanced for statement, there is a program part that we want to repeat embedded in curly brackets. The cycle goes from element to element in the array and executes the program code each time, so the loop will go as many times as the length of the array. Let's see now how the while loop looks like in practice. We have an empty code here, so I create a boolean first, which is going to be the condition, and the initial value for this is going to be true. Now I'm going to create the while here. While condition equals to true, the loop is going to do what we are saying. But as you can see, we have a boolean here, so we don't have to say if it equals to true or not. We can use a shorter form like this, just while con. And this is already it. So we have a while loop here. But this is an infinite loop because there is nothing in it. I'm gonna print out something to see. Yeah, just the text infinite. If I start it like this now, you will see that it never stops because the condition never changes inside the loop. Yeah, and it goes on and on and on and on and on and on. I have to stop it here, otherwise we have to sit here till the end of time. So this is not great. Like this. I put the opening and the closing brackets because we are going to have more sentences, more lines. Well, we have to change the condition here. To be able to do this, I create an integer also. Yeah, idx, which starts from 0, and just simply write if idx is greater than 100. Yeah, cond false. We set the condition to false. And I still have to do something with idx because the value of idx is not changing, so I increment it like this. So this will start for IDX from 0. In every while loop, it will increment it here, and the end, it's gonna, when it reaches 100 and 1, because it has to be bigger than 100, sets the condition to false, and the while loop ends. Yeah, we have it. The text. I should have changed the text here because it's not infinite anymore, and just say IDX is IDX, for example. Yeah, and the IDX is written out here, so we can see how it works. Yes. But it can happen, for example, that I started with a false value. If I initialize cond to false, then the while loop is never going to run. So there will be nothing written here because it didn't even go in this place. Now the difference between the while and do while loop we are going to see very soon. I'm gonna make a do while loop from this one, copying, technique, and well, say here do, and start the cycle. I think this is correct. So now, if we set it to false, we should have one line at least. Yeah, IDS is 0. So it ran one time, and after it, program checked if the condition is true or false, and it was false. Of course, if I change it to true, it's gonna work like the previous one. So it's gonna run more than 100 times. Yeah, that's it. Now that's the most major difference between the do and the while and the do while loop. I'm going to show you now how the enhanced for loop works. For this one, I'm going to create an array first. Let's make an integer array. Call it array. And this would be an integer array. I put some elements here, like very simple, like 2, 4, 7, 8, no matter, 5. And this is a simple array. Yeah, to write a new course here. And now we can create an enhanced for loop for it. We have to have a variable here, which is the same type as our array. Let's call it element. And a colon and the name of the array. That's it. And we are going to go over all the elements now. If I put a system out that print line here, we can simply say element. element. That's it. This is going to show us all the elements. Now save it and run. Yeah, you can see that all the elements are there, and it was more compact and very easy to use. But this is not all that this enhanced for loop knows that it can do. I want to show you how it works with more complex objects too. So for this one, I have to create a constructor here. I add some data also. Let's have an integer and a string here. And also boolean. Yeah. I'm going to create a constructor for this class, the test project. The test project class already has a default constructor, which is an empty constructor, of course. But this time I'm going to have these parts as well. I'm going to get the string as well and the boolean. So these are the parameters that we have to use when we create a test project. Class, and it's very simple. I just simply add the parameter values. Yes, and also the bool. Yes. Now this, after this, we can create special array which contains test project objects. Test project objects. Array is a new test project. Test project. Let's make it only 3 elements. Yeah, this is good, but in this array we do not have we have these test project objects, but they are empty. They're all empty. So I very quickly write put some data in them, so we can test how they look like. The array 0, the 0th element of the array should be a new test project. And let's say I put 2 in here. 2 is going to be the integer. Let's say a string is blue and, for example, true. And I'm just copying it to make it faster. Yeah. The first and the second. Also, let's make a little differences. Let this be 3 and this be 4, this be black, and this yellow, and one of them should be, for example, false. Okay, now we have the array ready. We don't need this anymore. Yeah, there is an error already because this is the for cycle goes with integers. This is not good. We want also the test project object type here, and that's how it can go through it. And if you want to show the elements, well, we just say element point dot a and element dot string, for example. And one more little trick, for example, we can say, well, only write this out if element dot bool, yeah, if it is true. So only write out the elements which has the true boolean part. That's it. Just save it and run. Yeah. 2 blue, 4 yellow. Yeah, I wanted to write here something like balls. So 2 yellow balls, 4 yellow balls. I mean 2 blue. So that's it. That's how it works with special types of elements when we have special object types, and it can go through any kind of array and collection as well. So this is very handy to use, I think, and very easy to see how it works indeed, and we don't have to use counters and anything. This is about the enhanced for loop. We are going to talk about conditional statements now. If we want to test whether a condition is true or false and decide to do something in the program or not according to the result of this test, the easiest way to do this is the if statement. There is also an operator which can be used to make decisions according to a condition. This is a conditional operator. We are going to talk about that as well. When writing a program, the if statement is one of the most frequently used kind of statements. Why is if statement so important? We have to tell the computer which statements we want to execute in a specific point of the program code and which code we do not want to run. This is a kind of decision that can be done according to a condition. And this is the role of if statement. How does it look like? It starts with the keyword if, followed by round brackets. These brackets contain the condition. The condition can be a statement that contains conditional operators like equal, not equal, smaller or greater, and so on and so on. Or it can be a Boolean variable or an expression. The if statements are followed by opening curly brackets and the program code that is going to run if the condition is true. This part ends with the closing bracket. If there is only one statement, we don't have to use the brackets. In case the condition statement is false, the program part between the curly brackets will not execute. If we want to tell our program what to do when the condition is false, we can add an else statement after the closing bracket of the if statement. After the else, we can place a program part that will be executed in case the if condition was false. It is also possible to use more than one conditions to decide at the same point of the program code by using the if-else-if statement. In this case, the program evaluates the condition one after the other and executes the program part that is after the first condition that was true. If none of the condition is true, we can write a final else statement that runs in this case. So we have three program parts now here, which are going to run according to the condition. The first runs when the condition 1 is true. The second is going to run if the condition 2 is true. The third part is going to run when the condition 3 is true. And the else is only going to run if none of these conditions is true. There is another way to decide between program parts considering conditions. There is a conditional statement which is called conditional operator or ternary operator. Sometimes it is easier and more compact to use this operator instead of if-else statement. This operator stands out of 5 parts: the condition test inside round brackets, the question mark, the statement to execute if the condition is true, a colon, and another statement that is executed if the condition was false. The ternary operator can be used many places instead of if-else. It may be harder to read, but there are some typical situations where it is very handy. For example, when you want to display time in 12 hours representation and place AM or PM before the text. And you have to decide between these two prefixes, considering if it is morning or afternoon. Now let's see the conditional statements in practice. First, we were talking about the if statement. Well, the if statement is the first and most important conditional statement. There should be a condition here. Well, I create two integers what we can do something with. One of them is A, it's going to be 2, and there is another one which is going to be B, and it's going to be like 7. Well, we say if A is smaller than B, then we write out something. Write out smaller. That's it. That's the most simple way to do it. Yes. This is a condition. This can be we can use conditional operators. We can say equals to B. Well, in this case, it won't work because they are not equal to each other. Smaller, greater, smaller, equal, and any kind of Boolean type of expression can come here. We can say Boolean, bool is true. Yeah, bool is true. Write out this. It's smaller. Of course, the text is not the best here now, but you can see that it works. What do we do? What do we do if, for example, we want to have the other part, the else part as well? So there's some kind of program part that runs, executes when the boolean is true. But we do have to have another part which is going to execute when it is false. Yes, we say false here. That's how it works. If this condition is true, then the true. If this is false, then the false is going to. But we are. I change it to false because you want something different to happen. Yeah, it says it's false because we came into this part. We can use the brackets, of course, as well. Just like here. We can use more. We can say A++ or anything like that. So we can use different program lines here. What if we want to have different conditions? We can use the else if statement. We have to give another condition here. Well, we say A smaller than B here. A smaller than B. Smaller. Maybe we can have another one as well, like B equals to 8 or something, and print out something if this is true. And at the end, we can still have an else. Which is gonna be just else. Yeah. We can try this out. It's a smaller, because this is the only true of them. But if we, for example, change them, if we change A to 9, then we have the else because none of the conditions were true. If I change B to 8, then it's gonna say 8. So this part ran. Yeah. I used the opening brackets here, but I didn't use them here because I only have one line. It's not obligatory, but that's how it works. Now we can also, it's also possible to try the conditional operator, the ternary operator. I'm going to show you that also. For example, we have a condition here like bool, and you're gonna have two parts, two strings. We say Mr. and Mrs. Mr. and Miss, and we are going to give it some kind of string. Name prefix. Yeah, of course, the most important part that was missing. So now we can see the 5 parts of the condition test. Is the first. The condition test is the first. The second part is here, the question mark, and we have 2 possible statements here, Mr. and Mrs., and the colon between them. So this is going to decide, for example, how to name someone, and we can write it out that Mr. or Miss name prefix, and that's it. Well, I put some extra string here. Well, we have to say that is it Mr. or Miss Sandman? Well, this should be Mr. Sandman, so I set it to true and see how it works. Yeah, it's Mr. Sandman. It's very nice, but I can put it also here just to make it more shorter and yes, just like this. So I can put it anywhere. I don't even need this. So this is how to use this conditional operator, ternary operator. For example, I'm gonna run this. Yeah. But in this case, the program added also the Sandman to miss, because I forgot also again the rounded brackets. So now we have our brackets here. So the whole conditional statement, the condition operator is between the brackets now. So the program, the Java will know now that this is a separate string part added to this, added to one of these, and it's going to be working just like previously. Yes. Now that is about the ternary operator or conditional operator and the if-else if parts, conditional statements. There is another way to handle the program when we have multiple conditions. The switch statement is designed for this aim. The switch statement starts with the keyword switch, followed by a rounded bracket that contains a variable that is going to be tested. Then comes the opening curly bracket and the first case keyword. After the case, we can specify the first possible value for the variable. The value used in this case statement can be a character, an integer, or a string, but this is only available from Java 7. If the variable has this value, then the program lines after the first case will be executed. After that, we can have another case keyword followed by another value. The program part after the case that has the value that matches the variable will be executed. Note that it is important to write a break statement after the program lines of each case program block, because this will tell the program to quit the switch statement. The break is a special keyword that we are going to talk about later in this chapter. After the case statements, we can use a default statement inside our switch. The program parts that are written after the default keyword are going to be executed if none of the case statements match the variable after the switch. Using the default statement is optional. Note that if we do not use default block and none of the case statements matches, then no code will be executed, nothing will happen. As I have promised, we are going to talk about the break statement now. This keyword is used when we want to exit some program block inside a loop or a switch statement. When we want to exit a loop programmatically and not consider if the condition is true or false, we can use break. The break statement ends the loop that contains the statement immediately. As we have already discussed, this is the statement that is responsible for exiting the switch statement as well. There is another statement that is frequently used in loops. This is the continue. It's a special keyword which makes any loop to step to the next loop period immediately. Wherever this word is inside the loop, the program will jump from that point back to the beginning of the loop's program block. If the loop is a for loop, the incremental section of the for statement will execute before the next loop section, so the counter will be incremented or decremented. During practical programming, we frequently meet situations when we have to use multiply loops. In these situations, sometimes we have to name a loop if we want to use the break or the continue. This is the situation when loops are embedded to each other. This means that we have a loop or we have more loops inside the loop. And this can be more than 2 levels deep structure. So we can have loops that are inside of 2 or even more outer loops. This is a much more difficult situation to handle. If we use break or continue in these situations, the statement will have effect on the inner loop, the loop which is the innermost. If we want to use the break for another loop, for an outer loop, we have to name that loop. We have to give a label to it. This can be done simply by writing a name before the beginning of the corresponding loop followed by a colon. Then we can write the name of the specified loop after the break or continue statement. This way, we can specify which loop we are going to apply the break or the continue on. We are going to talk compound statements now. In the previous topics in this chapter, and the previous chapters, I have talked a lot about program blocks enclosed by curly brackets. Now let us talk about these in details. These parts of the program are called compound statements. So the compound statements is a list of statements are grouped together with curly braces that indicate that these statements belong to each other. And these program blocks are usually under some outer statement in the code, like a conditional statement or a loop or a function declaration. There are some standard ways that are accepted by most programmers how we style these program parts, so that it is easier to read and to understand. I am going to show these at the practical demo. Let's see now how the switch statement works in practice. I'm going to set up an integer here, which is named variable, and I set the value to 5. Now create a switch statement where we can see how the case parts work. I write the variable here because we are going to check the value of it. And here come the case parts. I can simply write the values here, like 2, and the program parts that I want to execute after it. I just make a system out print line here. Yes, I see 2. Now, this is already working. But of course, I want to have more of these. And I shouldn't forget to write the break sentence here. Right, break there, and I'm gonna make a few more case parts. One of them is for 3. The next one for 4. And this one for 5. And we can try it out. Yeah, it writes 5 because it found the 5. Our variable has the value 5. All the case parts were checked, and this has run. Okay, but what happens if we change it to 50, for example? Then nothing happens. None of the case parts, none of the values here after the cases match the variable. It is good to write the default part so that if none of the values is good, we can say not found, for example. Not found. Yeah, it says not found. This is a simple switch. We can say that it works just as like we thought it would be. We can use the car type here as well. Of course, I have to put a character here like G, and I can use it here as well. I say O, I say H, I say G, and also S, for example, and run it. It says 4. Yeah, because it found the G here, which is our variable. Now let us leave it here, the switch, and continue on with talking about a little bit more about the break and the continue statements that we have mentioned. I'm gonna make a while statement here and just put true in it, which is going to be an infinite loop. If nothing changes the condition of the while, it's an infinite loop. And as this is fixed true expression, so it's not gonna change anything. Won't change it. So we have to do something else to avoid the infinite loop this time. So I say that I create an integer here, like idx, which goes from 0, and I say if idx plus idx is bigger or greater than 20, break. It's gonna get out of the cycle. And if we want to see what is happening, I just put a system out here with the value of idx. Well, let's check it out. Yes, it goes to 20 from 0. And also the previous parts are working as well. It's very nice. But what happens if you want to try the continue as well? There is an easy way, for example, to do this. I say that if idx is divisible by 3, is evenly divisible by 3, this means if we make a division by 3 on idx, the remainder after this division is 0, so it's evenly divisible. This case we say continue. Continue. What's going to happen? We come into the cycle with idx 0, and every time we come here, we check if the idx is evenly divisible by 3. I have to put the incremental part here, otherwise the idx is not going to change its value every time. So it's gonna be it starts with 0 and increment it every time the loop goes, checks if it is evenly divisible by 3, and if it is, then these parts of the program won't be executed because the continue is going to make some extra to the next loop. So we are going to step to the next loop cycle. Let's see what it is doing now. Well, we can see that idx 1, 2, and we cannot see 3 here because 3 is divisible by 3. 4, 5, no 6, there is no 9, there is no 12, there is no 15, and so on and so on and so on, because all the time these numbers we have here, the continue is going to work. Okay, this is very nice, but what happens if we put all this stuff, for example, into another cycle? The whole stuff we put into a fourth cycle, which goes from 0 until I is smaller than 45, I plus plus, and I say I put all this inside the bracket. I should have put, of course I wanted to put it here. So I put the switch and the while inside the for. What is going to happen? We have breaks here. This break lets us quit from the switch. This switch. This is the switch. This break and this and this and this is quits out of this switch. This continue lets us continue this while cycle, and this break also the same thing. Well, I don't want too many lines, so I just set it to 5. What's gonna happen? Yeah, the same thing is going to happen 5 times. 5 times again, 5 times again, 5 times again. Well, it's okay. We can say that it worked as we wanted. But, for example, if we want to make a program part, want to test a condition which quits the outer cycle as well, this fourth cycle for example, we have to name this cycle as I showed previously in the PowerPoint. Let's give a label to it. I name it outer 4. From now on, this is called outer 4, this fourth cycle. And I can say, for example here, that break outer 4. Yes, this means whenever we get here and IDX is greater than 20, we break not only this while cycle, but also this for cycle, which is the outer. Now let's see what it's doing. Yeah, we can see that it only runs one, just like before. The whole thing runs only once. Because the first time we reach it, we quit the whole thing. Of course, we can say that it's no relationship between the outer 4 cycle and the inner while. So there's no need for the outer 4. But I can use, for example, the I here, which is the counter variable of 4. And this way we can use something from the 4. And this time it also means that the IDS is going to start from I, which is 0, then 1, 2, 3, 4. And every time we come in here into the while cycle, it's gonna produce something different. but this version of the program doesn't let us to do more than one for cycle. So I change it a little bit. I don't break outer for anymore. I just say let's continue outer for. This means every time we get here, the IDX starts from I, which is gonna be greater and greater every loop period. And every time we find the IDX is evenly divisible by 3, we continue, but the outer 4, the whole 4 cycle. And to make it easier to see what's gonna happen, I'm gonna put a system out here with I, so we can always see what was the initial number here, the I, which is given to IDX later on. Let's run this. Well, it starts with I0. Of course, we always get the 4 string here in the switch. The IDX here is written in the system out. We first get 1 and then 2, and then the third time we are going to continue. So the outer 4, we come back here again and start with another number, with the 1. So this time we are going from 1. So in the while we have the number 2 first to check. And you can see that continue comes earlier, and so on and so on. And we only go until the IDX is 5, of course. When the IDX is 5, we come here inside the while and we increment it, we add 1. So it's divisible by 3. So we continue outer 4, and outer 4 is finished because the IDX, the I, was already 4, and that's it. Now that is how we can work with cycles inside each other and give names for loops, and use the continue and the break statements with names or without them. Let's talk about compound statements a little bit. It's a more general category in programming. We call compound statements every block that is enclosed by these curly brackets. For example, there is a compound statement which is belonging to the main method, which is enclosed by these 2 brackets that is highlighted by yellow here by NetBeans IDE. If I simply write it to a different line, then I can see that this whole part can be called compound statement. Normally, these compound statements are belonging to something, some statement like a for statement or a function, declaration, or maybe a loop or a switch or something like that. This indicates that these program parts belong together. What is important about them is that usually, while practical programming, we are trying to arrange the program code text in a way that it is easier to see what is belonging to what and what is below the other level of a statement, for example, that is enclosing our statement. For example, this switch statement is inside this for. So this switch statement is a part of a compound statement which is inside the for. So I type it a little bit to the right. So I use 4 spaces here to put it here, or maybe a tabulator tab. This way we can say that we can see that it is under the for. And also the switch. Inside the switch I use the switch and the case keywords are at the same level, same depth here, as you can see. But all the program parts that are belonging to the case parts are one tabulator further to the right. This is a kind of standard way that most programmers do it like. It's easier to read the text, the code text this way. Now that's about compound statements.